Okay, so real quickly, I'm just going to review, and then there's a couple of new things on the back of this. All right, first thing, extrema of function are those maxes and mins that we've been talking about. So we've gone through optimization, we've done all of that. We know the applications of it. The derivative at a relative extrema is either 0 or undefined. It's all review. Okay, we're not going to spend a lot of time on it. Critical numbers exist at x equals c if f of c is a relative minimum or maximum. Okay, they're critical at that point. All right, moving on. All right, here we go. Raleigh's theorem. This is important. There are lots of test questions over Raleigh's theorem. Okay, if f is continuous, which means there's no jumps, there's no asymptotes, there's no breaks of any kind, on the closed interval a, b, where a and b are the endpoints, and they are included in this. And it's differentiable on the open interval a, b. What does differentiable mean, like in normal terms to us? When it says differentiable, you think, yes, you're taking the derivative of it, but what does a function look like that is differentiable? What can it not have? Okay, it's not going to have breaks in it. Okay, and it's already said that it's continuous. What's the only other thing that you can't take the derivative of? Yes. Okay, what are those called? Anybody remember what they're called? Sharp, a point. A cusp. Okay, you can't take the derivative at a cusp. So if you go back to this first page, the derivative of the absolute value function, you can't take it at this point right here. You have to figure out a way to deal with that. The derivative does not exist at that point right there, at a cusp. No sharp changes. Okay, the derivative has to be smooth. All right. So that's what Raleigh's theorem is saying so far. It's got to be continuous and it's got to be smooth on this interval. Now that doesn't mean that the function somewhere else can't have a hole in it or a jump or an asymptote or a cusp. But on this region that we're talking about, it has to be continuous. It has to be smooth. All right, so that's what this means. Continuous, no gaps, and smooth. Okay, and if f of a, so if my y value at a is equal to my y value at b, then there is at least one number somewhere in there such that f prime of c is equal to 0. Okay? So, here is the deal. Let's look at this graphically. Graph the points 1, 3, so that point right there, and 5, 3. So there's 1, 2, 3, 4, 5. Draw the graph of a continuous differentiable function. Okay, so what does continuous and differentiable mean? No breaks. Between the 2 points. Is it possible to draw a function without at least one point between 1 and 5 where the derivative is 0? Try to do that. Try to do it. Try to draw a line where the derivative is not 0. Can anybody do it? No, you can't. All right. Did you do it, Charles?
No. I thought about it.
Okay. So that is Raleigh's theorem, and it basically says somewhere in between there it has to be 0. It could be everywhere in between there, right? It basically says that the slope somewhere is 0. So I could draw this graph like this. But it's got to get back down there, so it's 0 right here. I could draw it like this,
It still don't work. Yeah.
And now I have 2 places that it's 0. I could, maybe let's start trying this way.
No, dude.
No?
No, it didn't work.
I could just draw a straight line right through.
No, that's terrible.
Okay. All right, Charles, thank you for your commentary. This is Charles Headland, thank you. All right, so that's Raleigh's theorem. So, example, f of x is equal to x to the 4th minus 2x squared. Find all values in the interval -2 to 2 such that f prime of c is equal to 0. So I want to know what are those c's that make this equal to 0. First thing we need to do, though, is we need to find out what is -2 and what is 2. Or actually, the other way to do this is to say all of my values have to be between those 2 points. Okay, so let's find the derivative. F of x, f prime of x is equal to 4x cubed minus 4x. I want to set that equal to 0, so I'm going to factor out a 4x, and I'm left with x squared minus 1. So I get x equals 0, x equals 1, and x equals -1. Are all of those values in between?
Yes.
Yes. So we're good. Okay. So we do Raleigh's theorem. Raleigh's theorem is like, I mean, if you really think about it and understand it, it's like the theorem of Captain Obvious. Okay? It's impossible to not have a slope of 0 if 2 points are in the exact same y value. Right? I mean, it's impossible. So if you think through that, it's got to happen. It's got to be that case. What Raleigh's theorem is actually doing is leading us to the mean value theorem. And the mean value theorem is, you can see how it's spelled here. It's not because it's mean, angry, or bitter in any way. It's because it's the average is what we're talking about. Okay, and what this says, so if we read this, so this is the average is what we're talking about. If f is continuous on AB, the closed interval AB, and differentiable on AB. Does that sound familiar? That's exactly how Raleigh's theorem starts.
Wow.
Then there exists a number C in this open interval, AB. So we're talking about some value of C, some value of x. So here we go. Here's A, here's B. There's something in between here, some x value we call C, such that f prime of C is equal to f of B minus f of A over B minus A.
Okay.
What is f prime of C? What is f prime? The derivative of some point, right? Some x value is equal to, what is the right side of this? What is that called?
Definition of derivative.
If we had a limit on it, it would be. Thank you. This is the slope equation. All right, you guys remember that from 7th grade math? This is the slope equation. All right. So, in other words, you guys listen. I know, I get the feeling that y'all don't really want to pay attention to this, but you do. Okay, if you care about your grade at all, you do. There are lots of problems on the AP test that are mean value theorem problems. And I don't really get it because it's not a real hard concept. Once you get past all the mathlish and everything, it's actually a pretty easy concept. But there are tons of problems on it. Okay, so in other words, there is a point, an x value in the interval where the instantaneous rate of change is equal to the average rate of change or the mean rate of change over that interval. That's all that says. Typically the problems are things like, what is the value of C? Or like, so you find where C where C exists. Or they'll say, what value of A does this have to be for the mean value theorem to hold? All right, so just a real quick example. If I have A here and I have B here, and let's say A is way down here and B is way up there. All right, the average rate of change is this. Okay, that's my slope. Okay, y'all agree with that? So I'm looking for a slope that looks like that. Now, just like with Raleigh's theorem, try to draw a graph to where you get from point A to point B to where your instantaneous rate is not equal to that. It has to be. Okay, just like with Raleigh's theorem where the slope was 0, it has to be 0. So whatever we do, we can start going way up like this, and we can come down like this. Somewhere, this slope is my instantaneous slope. So if I look at this, probably like right in here, those slopes would be parallel. Or right down here, these slopes would be parallel.
So it's saying that it will always occur?
It happens. It doesn't say how many times, but it will happen once.
That makes sense.
Okay, it will absolutely happen once. So Raleigh's theorem is like a very specific case of the mean value theorem. Raleigh's theorem is when your slope is 0. Okay, mean value theorem is just a more general way of saying that. Okay. Example, 2 stationary patrol cars are parked 5 miles apart on a highway. A truck passes the first patrol car at 55 miles per hour. 4 minutes later, the truck passes the second patrol car and is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed of 55 miles per hour at some time during the 4 minutes. Here we go. We'll say at time equals 0, I have 55 miles per hour. 4 minutes later, this is at 50 miles per hour. And we want to prove that somewhere it had to be faster than 55, which used to be the posted speed in everywhere. Okay, so how can we prove that?
Well,
These are actually 5 miles apart. Okay, so 4 minutes, 5 miles. So how do we prove this? It went 5 miles in 4 minutes.
You can't do that without exceeding 55.
Why?
Because 60 miles an hour is a mile a minute, and if you're 5 miles apart.
Then you should have gone, it should have taken you how far?
Longer than 5 minutes, for sure. But if you made
Okay.
it 4 minutes, then you would.
Okay, do y'all kind of see how that, this is a video that a lot of times we show. This is like the example that everybody shows. So it's impossible to go 5 miles in 4 minutes, staying between 50 and 55 miles an hour.
all right, that makes sense.
Okay.
So,
Somewhere in between there, though, they did go at that average rate of change. All right, let's look at a real example. If C is a number that satisfies the conclusion of the mean value theorem, okay, and the conclusion of the mean value theorem is that f prime of C is equal to f of B minus f of A over B minus A. That is the conclusion. You need to memorize that. Okay, it will be on your tests. Okay, mean value theorem for f of x equals x cubed minus 2x squared on the interval 0 to 2, and it's included. So that means B is equal to 2 and A is equal to 0. So the derivative of this is what? 3x squared minus 4x. That's my derivative.
Oh, I see.
And that's equal to 2 cubed minus 2 times 2 squared minus 0 cubed minus 0 is what? 0. Over b, which is 2, minus a, which is 0. 3x squared minus 4x is equal to 8 minus, what is 2 times 2 squared? So 0 minus 0 minus 0 is 0 over 2. All right, so my average slope there is 0. This is Raleigh's theorem, but like I said, it holds for mean value theorem. So where does this happen? All right, and so that's when x is equal to 0 and when 3x minus 4 equals 0. And that's when 3x is equal to 4 when x is equal to 4/3. Those places it happens. If you look at let's just look at Raleigh's theorem real quick. If you look at the mean value theorem right here, what does that mean? And the AP test does this all the time. Okay, and you guys probably aren't even thinking about it right now, but what does that mean, AB? That's an interval. It's interval notation, and what does it mean? Between those 2 points, and do I include them?
Yes.
No. Not on the open parentheses like that. Brackets I do. So is this an answer? Is that an answer? It is the endpoint that we're talking about. And what did the theorem just tell me? I do not include the endpoint. So that is not one of my answers. That is. That, and I know it doesn't seem like a big deal. It is always on the AP test like that. So you will have a quiz. Could be as early as tomorrow if you're here. You are going to have to write the mean value theorem, just like I have it right here. You have to write this. Okay?
It's continuous through closed brackets,
but you don't.
With open brackets.
That's right.
Even the words?
The words, especially the words. Okay?